Yeah, hi everyone. I'm Akhilesh Nair. I'm a master's in computer science student at UIC, and today I'll be showing a quick walkthrough of the recent project that I've done as a part of the CS 441 course under Professor Mark Grechanik. So without wasting any time, let's dive into that. Uh, yeah, so basically the project was to implement an encoder for a large language model using distributed computing in the cloud, and we had to use Hadoop MapReduce to generate the word embeddings for a massive text corpus, and then we had to calculate the semantic similarities between those words. So, and the last part of the project was to deploy it on AWS EMR and to basically get the outputs through that. And yeah, I'll be going through the steps that I had taken to implement the project. So first was to shard the dataset and pass into the mapper reducers. Secondly, I've created four mapper reducers for this project, and I'll be going through each one of it. Uh, yeah, and after that, we also have to use a Jtokkit for the tokenization part. That is basically converting the words into words into tokens. And the embedding training has been performed using deep learning 4J, using its internal neural network. And the entire project has been done in Scala. Yeah, so let's dive into that. So I have created a bucket which contains all the folders containing the required files, required charts basically, that will be passed into the mappers and reducers. And I've also created a cluster, EMR cluster. I'm not going to the details on how to create this one, uh, just to keep the video short. So so let's create a first step. That is basically the first part of the project is to basically get the frequencies of the words in the entire data set and the required tokens. So I'm naming this one first job. I've already placed the jar over here, and the commands I've already written, so I'm not going to write it again. So basically, this is telling that to use this particular class, and I'm mentioning the input as well as the output folder. The output folder will be generated by itself. All right. So I'm going to run this. It's going to take some time. So till then, I'll pause this video. Yeah. So the job has been completed, and we have the output in the output folder. But I forgot to show you the input folder where the shards had been placed. So these are the shards. Now I'll show you the output that the MapReduce job has produced. Yeah. So for convenience, I'll just concatenate these part 3 files and show you the output as a CSV file. Yeah, so I've concatenated the files, and this is the output, wordcon.csv, and I have also downloaded the file. So the output looks like this. These are the words, the encoded tokens, as well as the frequency of each word. As you can see, the word Andy is occurring 3 times in the output. Yeah. Uh, the output of this particular map reducer won't be used as such anywhere. I'll be using a different, the second map reducer, which will be which will actually maintain the order of the input. This is not maintaining the order of the input. This is basically sorting the words alphabetically. So this won't be used to train the model as such. We'll be using the second mapper reducer to maintain the order. I'll show you. Let's run that one as well. I'm gonna name it second job, we are going to use the same jar. And also I'll be going through the code after this particular job. I'll go through that. So I've already created the HDFS files required, and so yeah, we have to copy the files that are placed in this bucket. I've placed the shards for this particular job in uh, order input. So these are the shards that we are going to use, and I'm going to copy this into the HDFS, which is which is running on the cluster right now. Yeah, so I've copied the files onto the HDFS. Now you're running this second job, basically the ordered word ME, and we have provided the input path as well as the output path for this. And I'm going to run this, and we're going to wait till this completes. In the meantime, I can show you the code for the first map reducer, the word count DP. So this is the Scala object that I created for this job, and here we are setting the number of reducers. For this purpose, I've used only 3 reducers right now. This is the mapper class, which will take each word from the dataset and convert into a key value pair, and the reducer will use it to basically count the frequency of each word and produce the output. For the tokenization part, I have used the Jtokkit that I have implemented in this class. The byte pair utils. This uses a Jtokkit. Basically, I've created 2 methods that will encode the text, meaning that it will create convert the word into its uh, particular token, and this will decode the token back into the word. Uh, yeah, and that's it for the first job. Now going to the second job, that is the ordered word ME. Uh, for this, I'm not going to go into the details. This is also basically doing the same thing. It treats the shards, creates key value pairs. The mappers creates the key value pairs, and the reducers will uh, write on the file, creating the output basically. The output I'll be showing in a moment once this job completes. Yeah, so the job has been completed, as you can see. Oh, and we can see the output file generated in the HDFS. For ease of viewing, I'm going to move these files to the S3, and I'm going to show you the output there. Yes, so I've copied the files to the S3, and as you can see, there are 3 files, output files, and I've concatenated them and created the ordered tokens.csv. And I can show you the output here. I've downloaded the file. Yeah, so this is the output. Basically, it contains the word position, the word, and the encoded tokens. So the word positions means that for example, this Robert, it means that it occurs in the first place in the dataset, and this is the corresponding encoded token. Now for the third mapper reducer job, which is for creating the encoding tokens, embedding tokens, we will be using the same output that the second mapper reducer produced, and we will be sharding this, and that will be used as the input for the third mapper reduce. Yes, so I've sharded the output and I've uploaded to the S3 bucket in the embeddings input folder. Now let's create the third step. I'm going to name this third job. I'm going to use the same jar that we had created earlier, and the file locations I'm going to copy from here. The third mapper reducer class is named embeddings generator. I'm going to walk through the code later on. Yeah, so let's run this. Yeah, meanwhile, the code is running. I'm going to show you the code for the third mapper reducer class. So yeah, this is the mapper. It's just going to take the tokens from the shards that we have created, and for each shard we are going to initialize a model, the ND4J model that we have created, and here we are defining the neural network configuration, initializing the neural network model, and it's going to run the for the number of epochs that we have mentioned. Right now it's around 20, I guess, 20, 25. And yeah, and then we are going to get the embeddings mapping for each token. And finally, the reducer writes into the CSV. Uh, oh yeah, first before that it computes the average of these vectors that we had calculated in the mapper task, and then it will write into the CSV. Yeah, the job has been completed, as you can see in the logs as well, and the generated output files are available in the embeddings output folder. Again, I'm going to concatenate these files and create the embeddings.csv, and I'll show you the output then. Yeah, uh, so this is the concatenated embeddings.csv file, and I have downloaded it here. Uh, yeah, the output looks like this. This is the token IDs, the words, and the embeddings. This is vector embeddings, and the dimensions are 50 right now. I've set it as 50. Uh, this is the token ID, this is the corresponding words, and the embeddings. And this particular output will be used for the fourth mapper reducer. So we are going to shard this as well, and this is going to be fed as the input for the fourth mapper reducer job. And our fourth task is to find the cosine similarity between each words, and I'm going to show you that. The fourth mapper reducer job, I've named it as semantic representation, and let me just name it fourth job. I'm going to use the same jar file, and the command I'm going to copy from here. Yeah, so as I said, the name of the class is semantic representation. This is the input path, the output path, and the number of the top words that will be similar to each word. I'm going to show you the output later on. Don't worry. So let's run this task. Uh, I forgot to show you the sharded files that I had placed for this particular job, and it's in the semantics input. These are the shards, just in case. And while the job is running, I'll go through the code for this semantic representation. This is the mapper class. We basically split the CSV, the sharded CSVs, and the third column of that shard was the word, right? And yes, so we'll be joining all the embeddings into a single string that will be sent as key value pair to the next to the reducers, And in the reducers, we are going to compute the cosine similarities. I've created a separate function for that. You can go through that, go through this if you want, and I'll show you the output. Then it will be much more clear. Yeah. So as you can see, the job has been completed, and also we have the output in the semantics output folder. And again, I'm going to concatenate these, and I'm going to turn it into a semantics.y YAML file, and I'll show you the output then. Yes, so I have concatenated the files, and this is the semantics.yaml file. I've downloaded it. Yeah, so this is the output, and what this means is that these are the five words that are more similar to this word diff. These are the top five words. We can define the top value. We had defined the top value when we had run the job, and yeah, so this means that the word salary is closer to these particular words. I hope that makes sense. And yeah, so this was the scope for this project. And talking about the future prospects, in the second phase of this project, we have to train the decoder, and the files that we have generated, that is the embeddings as well as the cosine similarities. We'll be using this to train the model so that it will be able to generate text, and that will be done on Apache Spark. And finally, in the third phase, we'll be building an LLM based generative system using Amazon Bedrock, and we'll be using AWS Lambda functions to handle client requests. Uh, yeah, so that was it for this video, and I hope you liked it. I'll see you in the next one then. Thanks.